changes, sublimation, expanding on heating, contracting on cooling. We know that solid substances on heating turn into liquid. But there are some substances that directly change into gas. Let us see how. These iodine granules are solid at room temperature. They are dark purple in color. Let's see what happens when we heat the iodine granules. Normally, we expect that it would heat up and then melt into a liquid. But iodine is a special substance. It sublimes. What happens when we condense the gas? We can collect it on a cooler surface and condense it. Again, it turns directly into a solid. There is no liquid state. The change of solid substance directly into a gas without changing to liquid first is called sublimation. We know that iodine has no liquid state. It directly changes from solid to gaseous state. This is called sublimation. Have you heard of tincture of iodine? It's a liquid. How is iodine a liquid then? Well, it's not a liquid. It's a solution of iodine in water. Think of a salt solution. You add salt to water and dissolve it. The salt doesn't turn into liquid. In the same way, iodine becomes a solution. It does not become a liquid. Materials expand on heating and contract on cooling. The amount of expansion differs in solid, liquid, and gases. Let us see why this happens. All particles in a substance are always vibrating. When we heat the substance, the particles get energy. Heat gives them energy to vibrate more. They vibrate faster and faster. As they do so, they move further and further away in the vibration. Their bonds become loose and they don't remain so close to each other when they move apart. The substance expands as it occupies more space. In solids, the particles are very close to each other. The particles hold each other very tightly. When you heat these substances, solids expand a little, but gases expand a lot. That's because particles in a gas can move further away from each other than particles in a solid. In liquids, the particles hold each other a little loosely, so they are a bit further away than solids. In gases, they hardly hold each other, so they are almost free of each other. Expansion in solids. Have you observed the railway tracks closely? There are gaps seen in between. Why is it so? These small gaps are called expansion gaps. The gaps are left deliberately as there is expansion of rails in hot weather. There is enough margin for the tracks to expand and contract due to the temperature changes. Look at these straight rail tracks. And these are buckled rail tracks. Buckling means if there is no gap, the track expands and bends in places. If no gap is left, the expansion will cause the rail tracks to buckle. If the rail is not straight like it should be, the train wheels cannot stay on the track. It goes off the track. That is called derailment. When it happens at high speeds, we have a nasty accident. Expansion in liquids. Water expands on heating. Take a glass filled with water to the brim. Pour water from the glass into a container and heat it. Do not boil. Now try to pour the water back into the same glass. The water overflows. Mercury is in the bulb of the thermometer. The thin tube inside is connected to the bulb. So the mercury in the bulb can move up and down in the tube. To check the temperature, the bulb has to touch the object. When the mercury expands, it cannot fit in the bulb and it overflows into the tube. How much it expands depends on how hot it becomes. And that is how we get the reading and understand what the temperature is. Expansion in gases. Watch this video. What happens when the air expands? How does it make the balloon grow in size? The balloon will grow in size as the air inside the bottle expands on heating. Cooling is the opposite of heating. It causes a material to contract. When we cool substances, the particles lose energy and begin to vibrate slowly. The particles come closer and closer together. Their bonds become tighter. They take up lesser space. So the substance contracts when cooled. Thus, when you heat these substances, solids contract the least while gases contract the most. That's because particles in a gas are quite far away from each other and can squeeze in a lot. Solids don't have that much extra space to squeeze in, so they can't contract that much. Contraction in solids. Have you seen a metal rim attached to the cart wheel? Do you know how the rim is attached to the wheel? A rim little smaller than the wheel is taken and heated. As heating expands the rim, it becomes bigger than the wheel. So, it slips over easily on the wheel. On cooling, the rim contracts and fixes firmly to the wheel. Contraction in liquids. We have seen that water expands on heating. Can you guess what will happen if the water is allowed to cool down? What will happen if the water is poured back into the glass? Contraction in liquids. Would it still overflow? No. The water fits exactly up to the brim in the glass. This is because of contraction. Contraction in gases. If an inflated balloon is tied at the mouth of a bottle and the bottle is placed in ice-cold water, what will happen? The balloon will shrink in size as air inside the balloon contracts on cooling. What did we just learn? The change of solid substance directly into a gas without changing to liquid first is called sublimation. The amount of expansion differs in solid, liquid and gases. Gases expand the most while solids expand the least. Solids contract the least while gases contract the most.